Welcome, dear listener, to this quiet corner of the night where the universe feels a little softer, a little slower, and wonderfully calm. I'm so glad you're here. As you settle into your pillow and let the day drift behind you, imagine that you've stepped into a peaceful observatory beneath a wide, star-filled sky. The world outside has dimmed, the sounds have grown gentle, and this is now a space just for you, a place where your mind can float freely, unhurried and unworried, wrapped in the hush of cosmic stillness. Tonight, we will explore one of the most soothing ideas the universe has ever offered, the dreamlike possibility of wormholes, those graceful, theoretical tunnels woven into the fabric of space-time. Before we begin drifting into this serene scientific journey, I'd love to gently invite you to like this video, subscribe to the channel, or leave a quiet comment below, perhaps a small note about where you're listening from, or simply a peaceful emoji to mark your visit tonight. You can do it now, before your eyes grow heavy and the stars of this story draw you slowly towards sleep. Thank you for supporting this calm little corner of the cosmos. Let's begin. Imagine, for a moment, that the universe is not a cold or distant expanse, but a soft, stretching fabric, something pliable, almost like a vast cosmic quilt. This quilt is woven from space-time itself, the interlaced threads of space and time that create the stage on which everything happens. According to Albert Einstein's theory of general relativity, this fabric is not static or stiff. It bends and dips and curves in response to the presence of mass and energy. A star causes a gentle indentation. A galaxy creates a grand, sweeping valley. Even you, lying quietly right now, create the slightest impression in this universal cloth. In this way, gravity is not a force pulling downward the way we often imagine it, but the gentle flow of objects following curves in the fabric beneath them. In this soft, curved universe, wormholes arise not as wild inventions of science fiction, but as mathematical possibilities whispered by the equations of relativity. If space-time can bend, Einstein reasoned, then perhaps it can bend enough to fold back on itself, creating a tunnel, a passage where two distant regions touch. The idea is similar to taking a sheet of paper with 2 points far apart and folding the sheet so that the points come together. Instead of traveling across the long separation, one could travel through a shortcut. Physicists sometimes call these pathways Einstein-Rosen bridges, and while they remain unconfirmed in physical reality, they sit calmly inside the mathematics, waiting like quiet doorways the universe has not yet opened for us. Picture these theoretical tunnels not as harsh or jagged, but as smooth, serene arcs carved gently by the laws of physics. They are bridges sculpted from the very geometry of the cosmos, as though the universe itself has drawn elegant pathways through its own depths. In their most basic description, wormholes connect two mouths, two openings located in different places or even different times. Between them lies the throat, a narrow tunnel curving through space-time. If you could float inside one, you would not see swirling chaos or violent spirals. Instead, you might see soft gradients of warped starlight, like the way light shimmers through water at dusk. Even though we have no evidence that such a journey is possible, imagining it offers a deeply restful kind of wonder. inviting your mind to stretch gently into possibilities without any pressure to solve them. The mathematics that allow wormholes arise from the very heart of general relativity. Einstein's famous field equations describe how mass tells spacetime how to curve, and how curved spacetime tells mass how to move. This interplay is like an endless, elegant dance, every object shaping space, and every shape guiding motion. Within these equations, wormholes appear as solutions, as if nature allows them in theory, even if it never chooses to build them. The physicist John Wheeler, who helped popularize the term wormhole, once described spacetime as a dynamic, restless sea full of frothy geometry at incredibly tiny scales. In that view, wormholes emerge as natural possibilities, tiny flickers of structure hidden beneath the calm surface of the everyday world. As you drift deeper into this gentle cosmic landscape, take a slow breath, as though you are inhaling the quietness of a starry night and exhaling the last remnants of your day. The thought of wormholes becomes easier to hold when the mind is loose, relaxed, and open to imagery. Picture them as softly glowing passages, not blazing or turbulent, but warm with the same gentle light that seems to settle in old libraries or early morning meadows. Their existence doesn't need to be proven tonight. It only needs to be imagined, lightly, as though you're letting the idea rest on your palm like a feather. To understand wormholes more deeply, we can move slowly through the idea of space-time curvature. Gravity, in the Einsteinian sense, is simply geometry. A planet orbits a star because the star creates a curved shape around itself, and the planet follows that curve in what appears to be a natural path. Even the motion of light can bend, drifting along these warped lines in the cosmic cloth. If the curvature becomes extreme enough, if space-time is folded inward with enormous intensity, the landscape can twist into tunnels that connect far-flung regions. These tunnels, if stable, would represent shortcuts through the cosmic texture. It's a bit like walking through a dense forest. Instead of following a long, winding trail around hills and ravines, a secret footpath might cut directly through. Most theoretical wormholes that arise naturally in Einstein's equations are not stable. They pinch closed almost instantly, like a bubble popping before you can touch it. To keep a wormhole open, scientists speculate that something very unusual would be required: a form of matter with negative energy density. This hypothetical substance is called exotic matter, not because it is fantastical, but because it behaves differently from anything we encounter in daily life. Instead of exerting a gravitational pull, exotic matter would push outward, counteracting the wormhole's tendency to collapse. It would act like a delicate internal scaffolding, holding the tunnel gently open and allowing something to pass through. Negative energy may sound like a mystical notion, but physics already contains phenomena that resemble it. The Casimir effect, for example, arises when two uncharged metal plates are placed extremely close together in a vacuum. The emptiness between them is not entirely empty. Quantum fields dance even in a vacuum, and the plates interact with these fields in a way that creates a tiny negative energy region. It is a subtle, almost poetic demonstration that the universe's emptiness is not truly empty, and that its deeper rules may be far stranger and gentler than we thought. If exotic matter exists in more abundant or controllable forms, It might someday support a wormhole the way roots support an underground burrow, quiet and hidden, but structurally essential. As we move through this soft exploration, imagine the universe as a vast landscape filled not only with stars and galaxies, but with countless unseen curves, folds, and passages. Wormholes may never be built, but the fact that they belong to the mathematics of our reality hints at a universe that is more flexible, more imaginative, and more interconnected than it appears. There is something soothing in knowing that even if the cosmos seems distant or immense, it contains secrets that are surprisingly gentle, like the fold of a blanket or the hollow inside a seashell. These tunnels are not violent ruptures in space. They are graceful possibilities, symmetries, and solutions whispered by the laws of physics themselves. The human mind has always been drawn to ideas like these. Long before modern physics, ancient cultures imagined ladders to the heavens, sky roads made of light, or hidden gateways between worlds. These early mythmakers sensed what we still feel today, that the universe is too vast, too beautiful, and too mysterious to be limited to straightforward paths. When we imagine wormholes, we are tapping into a very old yearning, the quiet desire to travel freely, to bridge distances instantly, to move without friction through the cosmos. Psychologists note that imagining impossible journeys can ease the mind, offering a sense of openness and release. It is as though imagining a shortcut in the universe also creates a shortcut in our thoughts, a gentle path through the forest of daily worries. Scientific thought experiments often serve this purpose as well. Einstein himself loved imagining simple scenarios that unlocked profound truths. A beam of light passing over rooftops, a person falling freely in an elevator, the steady ticking of two clocks separated by speed or gravity. These thought experiments were not just scientific tools, they were acts of imagination that stretched the mind into new shapes. Wormholes belong to this same tradition. They invite us to think with curiosity rather than tension, to explore not with urgency, but with wonder. Picture, if you like, drifting inside a wormhole, as though you were floating through a softly illuminated tunnel. The walls are not solid surfaces, but smooth gradations of curved spacetime, light sliding along their shapes like polished stone. In the distance, one mouth of the wormhole glows faintly, leading to a region of the universe unimaginably far away. In the other direction lies the familiar world, the one you know. You are suspended between them, unhurried, the universe gently arched around you. There is no rushing wind, no feeling of falling, just a slow, dreamlike glide through geometry itself. Scientists sometimes describe wormholes using embedded diagrams, showing how a two-dimensional surface can be imagined curving into a third dimension. These diagrams are simplifications, but they help reveal the idea that wormholes are not holes at all, but bridges. They represent smooth connections between 2 points, a reminder that the universe may contain hidden contiguities, subtle relationships between places that seem distant on the surface. When physicists say the universe could be multiply connected, they mean that there might be pathways woven into the cosmic fabric that are invisible yet real, waiting patiently like secret corridors behind old walls. Even if wormholes remain theoretical, thinking about them can calm the mind. They encourage a kind of cosmic perspective, the sense that life is embedded in something vast and intricate, where beauty unfolds at every scale. Just as rivers carve paths across continents and tree roots weave through soil, space-time may hold its own hidden channels, connecting distant regions with quiet continuity. Letting your imagination drift toward these peaceful possibilities can ease the tightness of the day and make room for rest. And so, as you lie here under the soft glow of imagined starlight, allow the idea of wormholes to become a gentle companion. Think of them not as portals to adventure, but as symbols of connection and unseen harmony. They remind us that even the most unimaginable distances might be bridged, that the universe carries quiet shortcuts within its folds, and that every point in space might be closer to another than it seems. In this way, wormholes become metaphors for comfort, a whispered suggestion that there is always a path forward, always a way through, always a gentle curve leading somewhere new. The night deepens around you, calm and spacious, and the fabric of space-time stretches softly in every direction, holding you just as it holds galaxies, stars, and every wandering particle. You are part of this cosmic tapestry, resting within its curves, wrapped in its quietness. As we continue our journey in the next part, we'll drift even deeper into the science and serenity of wormholes, letting their quiet mysteries guide us toward even greater calm. As we drift deeper into this quiet exploration, imagine that the soft, cosmic landscape from before has widened around you, giving way to an even more expansive calm. The stars glow like distant lanterns suspended in a vast, tranquil sea, and the universe stretches in every direction with a quiet confidence, as though it has all the time in the world to unfold its mysteries. Wormholes, those serene mathematical doorways, await us deeper in this night's journey, and now the mind has settled enough to follow their soft curves with ease. We move forward without urgency, as though walking along a gentle shoreline where each wave erases the footprints behind us, leaving only the present moment. Wormholes often feel like concepts too grand to grasp, but when we approach them slowly, like wandering through the halls of an old observatory, their nature becomes clearer. These tunnels of space-time are not objects you might hold or structures you could build with simple tools. They are more like patterns, graceful arrangements shaped by the laws of general relativity. In the vast field of physics, patterns often reveal more truth than individual pieces. A bird's migration is not understood by studying a single feather, but by watching the whole flock sweep across the sky in rhythmic waves. In this same way, wormholes come from watching how space-time behaves on a cosmic scale, from seeing how mass bends, how energy moves, and how geometry responds. To imagine a wormhole more deeply, think again of the universe as that continuous cosmic fabric. At first glance, it appears smooth, like a sheet stretched out beneath you. But if you lean closer and let your imagination soften, you might begin to see subtle folds and ripples, like gentle creases forming where the universe shifts under its own weight. These folds are not dramatic or violent. They are the natural result of mass curving space-time. Stars create curves, black holes create deeper depressions, galaxies sculpt entire valleys, and somewhere, in the mathematical edges of these shapes, there exist paths that can bend inward in such a way that distant locations could be quietly joined through a tunnel. A wormhole is fundamentally about connection, about the possibility that two points, no matter how far apart, might be linked by a hidden continuity. Philosophers throughout history have contemplated the nature of connection, how one thought leads to another, how one moment ties itself to the next, how memories bridge the past and the present. In a soft, symbolic way, wormholes echo these themes, offering a cosmic version of intimacy across distance. They remind us that separation may sometimes be an illusion of perspective, and that beneath the surface of things, there may be patterns that unite what seems far apart. Consider, too, how the human experience interacts with distance. For thousands of years, we believed the stars were fixed lights on a dome, close enough for myths and stories to touch. As knowledge expanded, the cosmos grew larger, more intricate, and more spread out, and yet our yearning to feel connected to it never faded. Wormholes, though entirely theoretical, offer comfort in their suggestion that the universe might allow closeness across great spans, even if they remain forever inaccessible. Their presence in the equations feels like the whisper of a kind idea. The universe might be large, but its structure contains pathways that gently hint at closeness, as though hidden bridges lie just out of sight. In the mathematics of general relativity, wormholes appear as solutions that satisfy the same elegant equations governing black holes. Black holes themselves were once purely theoretical, predicted long before the first indirect evidence confirmed their existence. The equations described objects so dense that space-time curved inward upon itself, creating regions where nothing, not even light, could escape. These predictions seemed almost fantastical to early physicists, yet they were accepted because the mathematics remained consistent. Wormholes share this peculiar status, hypothetical, unobserved, but woven cleanly into the fabric of the theory. Their existence in equations does not guarantee they appear in nature, but it does suggest they belong to the universe's architectural blueprint, waiting patiently like unused rooms in an enormous mansion. The idea of a wormhole often begins with the Schwarzschild solution, one of the first exact solutions to Einstein's equations. This describes a non-rotating black hole, a simple but profound shape in the geometry of space-time. For a brief moment in the mathematical description, this solution reveals a bridge-like structure, a connection between two regions. However, this early wormhole pinches closed too quickly for anything to pass through. It exists only as a fleeting shape in mathematics, like a door that appears for an instant before fading back into the wall. Later models, including traversable wormholes explored by scientists like Kip Thorne, require exotic matter to hold them open. These are the wormholes we imagine when thinking of tunnels that could allow travel, even though we still do not know whether nature permits such exotic matter to gather in meaningful amounts. In this particular landscape of theoretical physics, exotic matter acts not as a magical substance, but as a balancing force. Most structures in the universe tend to collapse under gravity unless supported by internal pressure or some external force. Stars maintain their shape through the pressure of nuclear fusion at their cores. Planets hold their form through the delicate equilibrium between internal structure and gravitational pull. A wormhole, to remain open, requires a different type of support. something that pushes outward rather than pulling inward, a stabilizing pressure that counters gravity's instinctive tendency to close the tunnel. Exotic matter with negative energy density fits this role in theory. Its presence within the throat of the wormhole would hold the geometry in a steady configuration, much like a lantern frame supports delicate paper walls. Negative energy is not as strange as it first sounds. In quantum field theory, energy is never simply empty or absolute. Even the vacuum contains fluctuations, tiny, momentary appearances of particles, antiparticle pairs that bloom into existence and vanish again. These quantum behaviors underlie phenomena like the Casimir effect, where the presence of closely spaced plates influences the vacuum energy between them. The energy density in this region becomes slightly less than the surrounding vacuum, creating a measurable force. Though faint, this effect proves that negative energy is not a fictional construct but a real feature of quantum physics. In this way, exotic matter becomes a concept grounded in known principles, rather than pure sci-fi invention. Imagining negative energy can feel abstract, so let it take form in a softer metaphor. Think of gravity as a gentle inward pull, like hands drawing fabric together. Exotic matter would be like a quiet outward breath, subtly pushing the fabric apart. The result is balance, a delicate equilibrium that could keep a wormhole's throat from collapsing. If such matter existed naturally in large quantities, it might shape the universe in ways we have not yet recognized. Perhaps it hides in the silent spaces between galaxy clusters or in the subtle rhythms of dark energy. Or perhaps it remains locked in the tiny scales of quantum reality, appearing only in fleeting whispers too faint for us to capture. Throughout history, scientific ideas have often begun as invisible possibilities, becoming real only decades or centuries later. Electricity hummed through the world for millennia before humans learned to harness it. Atoms were spoken of in ancient Greece long before microscopes or particle accelerators proved their structure. Even the idea of time dilation, that time can stretch or compress depending on speed and gravity, remained abstract, until astronauts, satellites, and precise clocks demonstrated it daily. Wormholes may belong to this lineage of patient ideas. They may remain theoretical forever, or they may someday reveal themselves in subtle gravitational signatures or peculiar cosmic alignments. For now, they remain a concept that comforts simply by existing in mathematics. As you imagine the structure of a wormhole, let the tunnel become more than a line or a shape. Envision it as a place you can drift through slowly, like a quiet hallway lined with soft light. The entrance, or mouth, might appear as a circular opening surrounded by shimmering distortions, not harsh or blinding but gentle, like the blur of heat on a summer road. Step inside, and the space around you shifts subtly, the curvature smoothing into a graceful arc. The geometry becomes your guide, leading you through without the need for propulsion or effort. The walls, if they can be called walls, are gradients of bending spacetime, luminous yet calm. The tunnel expands and contracts with steady symmetry, as though breathing softly in the silence of the cosmos. In this vision, the wormhole becomes a serene transition, a journey through a landscape of pure geometry. Somewhere ahead lies another mouth, opening into a region of the universe so distant that light itself would have taken centuries or millennia to reach it through normal space. And yet here, through this theoretical tunnel, the distance feels gentle, reduced to a graceful curve that the universe has folded for you. This is the poetic essence of a wormhole, not a shortcut built through effort, but a possibility arising from the universe's own elegant design. To better understand the geometry involved, physicists sometimes use embedding diagrams, which show a two-dimensional slice of spacetime curved into a third dimension. These diagrams are like artistic cross-sections of something grand and unseen, revealing tunnels and bridges that cannot be easily visualized in flat drawings. They help us grasp how a wormhole's throat forms and how it connects separate regions. Though simplified, these diagrams feel almost meditative in their symmetry. A smooth curve dips downward, narrows, then rises again, a shape that repeats across many forms in nature, from riverbeds to roots to hollow tree trunks. Even in their abstraction, these diagrams carry a quiet familiarity, as though the patterns of the cosmos reflect the patterns of the Earth. As the universe expands, distant galaxies drift further apart, carried by the stretching of space-time itself. But wormholes hint that some distances might be bridged by other means. In a sense, they suggest that the universe may not be strictly limited to the expansion we observe, that layers of connection might lie underneath the stretching surface, like hidden tunnels beneath a growing city. Even if we never find or create a wormhole, the concept helps us imagine the cosmos not as cold and unreachable, but as flexible and full of hidden architecture. The beauty of physics lies partly in these possibilities, these hints of deeper structure that invite us to wonder. Humanity's fascination with hidden pathways goes back to the earliest stories. In African mythology, the sky and the earth were once connected by a long, living vine, which allowed people to climb freely between the two realms. In Polynesian traditions, navigators imagined star paths as bridges across the ocean, guiding their canoes through darkness by connecting distant points of light. Norse legends tell of Bifrost, the shimmering rainbow bridge linking the human world to the realm of the gods. In all these tales, the idea of a hidden passage, a direct route to what seems far away, brings comfort and clarity. Wormholes, in their own scientific way, continue this tradition. They give shape to the timeless desire for closeness across the cosmos. Even the language we use to describe wormholes is filled with quiet poetry. We speak of tunnels, bridges, throats, and mouths, words that evoke familiar shapes and bodily sensations. A throat narrows, a mouth opens, a bridge spans a gap. These metaphors make wormholes feel less like cold abstractions and more like natural forms, almost anatomical expressions of the universe itself. Physicists sometimes describe these structures as handles or tubes in space-time topology. But beneath the technical language lies a simple idea: connection through curvature. As we continue this peaceful exploration, think of wormholes not just as theoretical structures, but as reflections of human curiosity. Each generation looks to the night sky with new questions, new hopes, and new dreams. Some dream of faster travel, some of deeper understanding, some of contact with distant civilizations. But beneath all these dreams lies a common thread: the desire to feel part of something larger, to know that what seems unreachable might not be so far after all. Wormholes embody that gentle hope. Even if they remain forever theoretical, their presence in our imagination brings comfort, as though the universe itself is whispering that it contains more possibilities than we can yet perceive. In this quiet moment, suspended between reality and imagination, let the concept of wormholes continue to unfold like a slow-moving river carving its way through stone. There is no need to hurry, no pressure to reach a conclusion. The universe is vast, patient, and endlessly intricate. Its secrets do not insist on being solved. They simply offer their presence, like stars twinkling from distances too great to measure. As the night deepens and the mind settles further, the soft geometry of wormholes becomes a gentle companion on your journey toward rest. As we continue drifting through this calm landscape of cosmic thought, imagine that the night around you has settled into an even deeper quiet. The stars above shine with a gentle steadiness, as though they are in no hurry to burn or fade, simply resting in their places across the sky. The universe seems to unfurl slowly, like the petals of a nocturnal flower opening in a soft breeze, revealing more of its hidden structure with each passing moment. It is within this restful stillness that we can explore wormholes further, tracing their gentle arcs and understanding how they blend geometry, physics, and imagination into one soothing concept. In the earlier parts of this journey, we considered wormholes as mathematical tunnels, bridging distant corners of space-time through smooth curvature. Now, with the mind more relaxed and the night stretched out around us, we can wander deeper into what these bridges might mean for the nature of distance, time, and connection. The idea that space can fold upon itself, creating shortcuts between remote points, suggests that the universe cares less about rigid separation and more about the relationships between things. Even if wormholes never physically form, the fact that they are allowed within the equations leaves a soft echo, a suggestion that the universe's architecture may be more flexible than it appears. Mathematically, wormholes are tied closely to the geometry of space-time, and geometry, in the cosmic sense, is not a simple set of lines and angles but a living structure shaped by gravity. Gravity, which we often experience as a downward pull, is better understood as the way mass and energy bend the cosmic fabric. The more mass something has, the deeper the indentation it creates. Even light, which seems weightless to our senses, follows these curves faithfully, bending around stars or black holes in smooth trajectories. This bending of light, known as gravitational lensing, is one of the clearest demonstrations of space-time curvature, and it acts like a natural magnifying glass, revealing distant galaxies that would otherwise remain unseen. If light itself can bend so gracefully through space-time, then imagining wormholes becomes easier. A wormhole is simply a curvature taken to an extreme, where the fabric folds enough to form a tunnel. In some models, these tunnels can be stable if supported by exotic matter. In others, they flicker momentarily and collapse. But in all versions, they represent the idea that the universe might contain hidden shortcuts. These shortcuts may not be functional or accessible, but they showcase the beautiful possibilities encoded in the mathematics of relativity. To picture this more deeply, imagine space-time as a calm, gently rippling surface of water. When a pebble drops into it, much like a star settling into existence, it creates circular waves. If two pebbles drop at once, their ripples meet, interfere, combine, and pass through each other. Now imagine that the water could be guided, bent, or shaped so that certain areas swell upward or dip downward, creating natural conduits where the ripples travel with remarkable ease. A wormhole would be like a channel carved through the water, allowing a wave to travel from one region to another through an elegant arch rather than expanding outward across the entire surface. Just as water can support currents, vortices, and underwater caves that connect distant points, these structures might be theoretical, but they reveal the underlying creativity of physics, not a creativity imposed by humans, but one emerging from the universe itself. Physicists often describe their work as a kind of listening, as though they are tuning their instruments and equations to hear the faint hum of cosmic truth. Wormholes appear in that hum like gentle harmonics, not loud, not overwhelming, just soft possibilities intertwined with deeper laws. Now, let us consider what wormholes could mean in a broader cosmic sense. If a wormhole connects 2 points in space, then travel through the tunnel would be instantaneous from the perspective of someone making the journey. But what does it mean for something to be instantaneous in a universe where time and space are interwoven? The answer rests in the flexibility of space-time. If two locations are linked through a wormhole, the path between them within the tunnel does not obey the same length as the path outside. To the traveler, the tunnel might be only a few meters long, even if the mouths of the wormhole are separated by thousands or millions of light years in normal space. This reveals a subtle truth about distance. It is not absolute. It depends on the structure and curvature of the path. In everyday life, this feels intuitive. A straight road might connect two towns, but a winding trail through a valley may stretch the journey much longer. In space-time, these ideas become profound. The shortest path between 2 points is not always a straight line. Sometimes it is a curve, or even a hidden passage through a folded dimension. This idea is at the heart of general relativity and the heart of wormhole physics. Let your mind drift to the idea of time now, not as a rigid timeline, but as a gentle flow. In Einstein's theory, time and space form a four-dimensional continuum, and wormholes could, in theory, connect not only distant locations, but different moments. This concept sounds dramatic in science fiction, but in scientific terms, it arises simply from the structure of the equations. If one mouth of a wormhole moves or accelerates relative to the other, the two ends can become time-shifted. This does not necessarily create paradoxes, nor does it guarantee time travel, but it does suggest that the geometry of space-time is more fluid than our everyday experience reveals. Imagining these possibilities can evoke a sense of timelessness, a gentle detachment from the rigid sequences that structure daily life. You might picture time itself as a slow-moving river, with currents that vary in speed depending on where they flow. In some places, the river widens, becoming smooth and leisurely. In others, it narrows into channels where time flows more quickly. A wormhole could be like a tunnel under this river, connecting one quiet bend to another. The traveler within it would drift through the tunnel in a peaceful suspension, emerging not only in a different place, but potentially in a different moment with the same quiet ease. As we explore this concept further, Allow your mind to rest lightly on the idea of symmetry. Many of nature's most beautiful structures arise from symmetrical patterns, from spirals in seashells to the radial shapes of flowers, from planetary orbits to the delicate curves of magnetic fields. Wormholes, too, have symmetrical properties, often described with balanced equations, mirrored throats, and smooth transitions between connected regions. Even when the mathematics becomes complex, these fundamental symmetries remain, offering a reassuring sense of order. In the center of these theories lies the Einstein-Rosen bridge, one of the earliest wormhole models. Though not traversable, it demonstrates how deeply geometry can respond to gravitational conditions. Later models by Wheeler and Thorne expanded on this foundation, exploring how exotic matter and quantum effects might create tunnels that remain open. Quantum theory adds its own layer of possibility, suggesting that space-time at the smallest scales might be far more irregular than our senses reveal. Some physicists imagine quantum foam, a frothy, bubbling substrate where tiny wormholes flicker in and out of existence. These wormholes would be unimaginably small, far too tiny for any object to traverse, but their presence further reinforces the idea that space-time itself is full of subtle complexity. To ground these ideas in something soothing and familiar, picture the roots of a large tree weaving unseen beneath the soil. The roots connect different parts of the forest floor, carrying water and nutrients through hidden channels. You may walk across the forest path completely unaware of the intricate network beneath your feet. In a similar way, space-time may contain networks we cannot perceive directly, tunnels, shortcuts, and gentle folds that move quietly beneath the cosmic surface. Even if we never touch them, the idea that they might be there adds a mysterious comfort to our understanding of the universe. As the night deepens further, let your awareness soften. You may find that the concept of wormholes begins to feel less like a technical idea and more like a gentle dream. The universe, vast as it is, contains countless mysteries, and wormholes represent one of the most serene and imaginative among them. The possibility of connecting distant places, of bridging great spans effortlessly, mirrors our own inner longing to feel connected, supported, and at ease. These theoretical tunnels become symbols not only of cosmic geometry but of emotional continuity, reminding us that distance, whether physical or internal, can be softened by understanding. In this quiet exploration, allow yourself to feel the spaciousness of the cosmos, a spaciousness mirrored in the chambers of your own thoughts. Hidden pathways exist in memory, imagination, and intuition. Just as a wormhole can bridge vast distances in space, your mind bridges past and present, weaving through experiences with gentle continuity. The brain is, in many ways, a universe of its own, a network of pathways, shortcuts, and associations, where ideas connect in ways both direct and surprising. Neuroscientists sometimes describe neural networks as dynamic webs, shimmering with activity. These webs form tunnels of thought, connecting distant memories in the blink of an eye. A scent from childhood can open a tunnel to forgotten rooms of the mind. A quiet melody can bridge decades, carrying emotion across time as softly as a whisper. As you reflect on these connections, let your body soften a little more, as though gravity has grown gentler. And if you feel comfortable, Allow your breath to move with slow, unhurried ease, like a drifting current in a calm sea. With each exhale, imagine the vastness of the universe settling around you like a warm, dark blanket, full of hidden pathways and quiet wonders. This is your second gentle reminder to let yourself unwind, to release the remaining tensions of the day the way starlight slowly fades into dawn. Let us return now to the larger cosmic scales, where galaxies form majestic swirls across the sky. Wormholes, if they exist, might appear between such galaxies, offering passages through interstellar space that bypass the long stretches of darkness between stars. Imagine drifting across these spaces inside a wormhole, emerging near a distant galaxy whose light has traveled billions of years just to reach us. The wormhole becomes a sacred corridor, a place of transition, where the boundaries of time and distance blur in a comforting way. Yet even without wormholes, the universe contains natural structures that echo their spirit. Cosmic filaments, vast tendrils of galaxies, and dark matter stretch across billions of light years, connecting clusters in a web-like pattern. These structures reveal how the universe forms networks at unimaginable scales, linking regions with delicate threads of gravity. On smaller scales, magnetic fields create invisible bridges that guide particles through spirals and arcs. Even smaller molecules form bonds that connect atoms in elegant geometries. At every scale, the universe seems to favor connection, weaving pathways both seen and unseen. This tendency toward connection is at the heart of physics. Electric fields connect charges, gravitational fields connect masses, quantum entanglement connects particles across distance, and wormholes, at least in theory, represent the most dramatic form of connection, a direct link between distant points in space-time itself. These ideas remind us that the universe is not a scattered collection of isolated objects, but a single, intricate tapestry, its threads woven through physical laws, geometric structures, and hidden possibilities. As the journey continues, imagine walking along a quiet path inside a cosmic cavern, its walls glowing faintly with starlight. Ahead, the tunnel branches into countless pathways, each representing a different theoretical possibility the universe might hold. Some lead to stable wormholes supported by exotic matter. Others lead to quantum fluctuations that flicker out as soon as they appear. Still others represent insights not yet discovered, ideas waiting quietly in the equations for curious minds to find them. You choose a path at random, not because it matters which one you take, but because each represents a gentle act of exploration, free from pressure or expectation. The concept of wormholes also touches on the philosophical. If the universe contains pathways that bypass distance, then our understanding of separation shifts. Space and time cease to be rigid barriers and become elements of a dynamic, connected whole. This mirrors the way life often unfolds. Moments that seem separate can become deeply connected upon reflection. Small decisions ripple outward, forming bridges to new experiences. Memories echo across years, touching the present in unexpected ways. We, too, contain wormholes of meaning, hidden passages linking past and future. consciousness and feeling, hope and memory. In the quiet of this night, let the idea of wormholes become not a question to be answered, but a space to rest within. Physics does not insist that you resolve these concepts fully. The universe offers its mysteries gently, allowing us to sit with them without urgency. Theoretical structures, like wormholes, act as invitations rather than demands, encouraging us to imagine, to wonder, and to relax into the soft edges of possibility. As we near the close of this section, you might feel the weight of the day dissolving further, replaced by a sense of spacious calm. This journey through cosmic geometry has been slow and unhurried, meant not to dazzle the mind but to soothe it. Wormholes, with their graceful curves and hidden pathways, serve as perfect companions in this nighttime exploration. Whether or not they exist physically, they exist beautifully in the imagination and mathematics, offering comfort in the idea that the universe is filled with subtle connections. As we drift onward into this deepening night, the universe around you seems to stretch into an even more serene expanse, as though it has settled into its most peaceful form just for this moment. The stars shimmer with a calm persistence, each one a quiet guardian of light, across unimaginable distances. Space itself feels softer now, more fluid, as though the fabric of the cosmos has settled into gentle folds. It is within this tranquil stillness that we can continue exploring wormholes, not as urgent puzzles to be solved, but as sources of comforting wonder possibilities that illuminate the hidden creativity of the universe. By now, the concept of wormholes may feel familiar, their geometry and gentle curvature woven into the quiet of your thoughts. But beyond their structure lies the question of what they represent: gateways to distant places, bridges between eras, or symbolic passages that echo the paths we seek within ourselves. Wormholes open the imagination to vistas far beyond the reach of conventional travel. They allow us to picture journeys that unfold along soft corridors of space-time, connecting places that starlight itself takes ages to cross. As we contemplate these possibilities, the universe becomes not just large but beautifully continuous, filled with paths that curve inward toward deeper meaning. Imagine drifting closer to the mouth of a theoretical wormhole now, suspended in an expanse where gravity and geometry blend into one seamless whole. The mouth might appear as a circular halo of shimmering distortion, a soft ripple in the background of stars. Light bends gracefully around it, not in chaotic spirals but in smooth arcs that resemble ripples passing around a stone in still water. This bending is a consequence of warped space-time, a visual whisper that something interesting lies within. The wormhole throat extends inward from this opening, narrowing gently before curving toward another region of space. Even if such a tunnel never forms in reality, its presence in mathematics allows us to visualize the universe as a place full of hidden architecture, much like a vast landscape shaped not only by what is visible but by what is possible. One of the most soothing aspects of wormholes is the invitation they offer to imagine distances reduced to moments. Consider, for example, the space between our planet and even the nearest star beyond the Sun, a star called Proxima Centauri, just over 4 light-years away. Light itself, moving at the cosmic speed limit, takes more than 4 years to travel that distance. A spacecraft using current technology would need tens of thousands of years. Yet within the soft geometry of a wormhole, that immense separation might be reduced to the length of a walk through a short tunnel. Although we cannot achieve such travel today, the idea encourages a peaceful sense of spacious possibility. It reminds us that the universe might contain shortcuts woven into its design, waiting quietly like unopened passages in a grand, ancient library. Let the idea settle gently, a universe where paths may exist beneath the surface, where the journey from one place to another could one day be as simple as stepping through a doorway. Even if that doorway remains forever theoretical, its presence in the equations softens the vastness of space. It hints that the universe is not indifferent or rigid, but flexible in ways that invite contemplation. It carries the subtle suggestion that everything might be more connected than it appears, that the fabric of reality contains hidden threads capable of joining distant regions with quiet elegance. As we move deeper, you may find that wormholes evoke a sense of wonder, not only because of their scientific implications, but because they resonate with old stories and ancient desires. Long before the language of physics existed, people imagined paths through the sky, routes traveled by ancestors or deities, bridges from earth to heaven. These stories were not technical explanations, but expressions of hope and imagination, the desire to transcend distance, time, and limitation. Wormholes, though rooted in relativity rather than myth, echo that yearning. They allow us to imagine connection across vast expanses, honoring a human longing that is older than astronomy itself. In many cultures, the night sky served as both map and metaphor. Polynesian navigators read the stars as pathways, using them to sail across immense stretches of ocean with extraordinary precision. Ancient Chinese astronomers envisioned celestial roads traced by the Milky Way. In Norse lore, the Rainbow Bridge linked realms in the heavens. In each case, the night sky was not a barrier, but a field of passageways, a realm where connection was always possible. Wormholes take this idea and weave it into the fabric of physics, suggesting that the universe itself contains possibilities that mirror humanity's oldest stories. As you think about these traditions, imagine the sky above you as a gentle canvas, filled not with unreachable lights, but with quiet invitations to wonder. Each star becomes a point on a map of potential journeys. Each constellation reveals a pattern formed not only by starlight, but by the stories we tell to remember that we belong to the cosmos, and it belongs to us. Wormholes, though scientific in origin, fit naturally into this ancient landscape of imagination. They remind us that space may hold more pathways than we can yet perceive, and that curiosity has always been our guide to discovering them. In exploring these possibilities, scientists often consider the mathematical distinctions between different types of wormholes. Some models describe tunnels that connect separate universes, while others connect distant regions of the same universe. Some are symmetrical, with identical mouths, while others form asymmetric shapes, depending on the distribution of exotic matter. These distinctions are subtle and intricate, but in a calming sense, they reveal how many ways the universe can shape itself. The variety of wormhole solutions demonstrates that space-time is not a simple, uniform backdrop, but a dynamic, creative field capable of forming structures far beyond our immediate perception. To imagine these variations gently, picture a series of possible wormholes forming like soft arches in a quiet garden. One arch leads to a familiar corner of the same landscape, perhaps just beyond a hill. Another leads to a distant meadow under a different sky. A third opens into a valley filled with strange, glowing plants. Each arch is supported by a delicate balance of forces, some stable enough to walk through, others ephemeral and fading. In this garden of cosmic possibilities, there is no rush to choose a path. Each arch offers a unique view, a hint of a world beyond, and simply contemplating them brings a sense of calm and openness. Another intriguing aspect of wormhole physics is the interplay between gravity and time. In relativity, time is not absolute but influenced by motion and gravity. Clocks tick differently depending on their environment. Near a massive object, time slows. At high speeds, time stretches. When wormholes are considered, these time effects become even more intricate. If one mouth of a wormhole experiences a different gravitational environment or moves relative to the other, the two ends could become out of sync in time. From one perspective, traveling through the wormhole might bring you into the future, from another, into the past. These scenarios do not necessarily create paradoxes. Rather, they highlight the gentle fluidity of time in the cosmic fabric. The idea of time bending or looping can be soothing when approached slowly. Imagine time as a flowing river with gentle currents. Most of us drift along the main channel, carried steadily forward. But perhaps there are quiet inlets and side streams where time pools momentarily before rejoining the flow. A wormhole might be like a hidden tunnel beneath this river, connecting two bends in a smooth, secret path. The traveler might emerge just a little earlier or later than expected, carried by the geometry rather than by the usual current. This image is not meant to be literal, but symbolic, a way to let your imagination rest gently on the idea that the universe holds many layers we have yet to understand. As the night around you deepens further, allow your thoughts to settle like falling dust in a quiet beam of moonlight. Across the vast scales of the cosmos, wormholes remind us that even the most dramatic distances can be softened by curvature and possibility. They are symbols of hope and continuity, of the idea that connection can exist in ways that defy ordinary limits. In many ways, they mirror the quiet ways human experience bridges its own distances. A memory can connect you to moments long past. A dream can transport you to imagined places. A feeling can bring you close to someone far away. These inner wormholes, though intangible, are no less real in the landscape of the mind. Scientists who study wormholes often move through their work with a blend of precision and wonder. The equations are exacting, the conditions demanding, and the mathematics intricate. Yet beneath all this lies the simple desire to understand how the universe might permit such structures. Theoretical physics is filled with these graceful tensions. Imagination, guided by strict rules. Creativity, balanced by calculation. Beauty, revealed through logic. In this balance, wormholes stand out as some of the most elegant possibilities nature has allowed us to glimpse, even if only through symbols and equations. As you reflect on these ideas, you might feel your body growing heavier in the most pleasant way, as though gravity is embracing you gently instead of pulling you downward. If you feel the urge, allow your shoulders to soften, your jaw to loosen, and your breath to deepen in its own slow rhythm. This is your final gentle reminder in the entire script, the last soft invitation to let yourself sink comfortably into the quiet around you, like a leaf drifting towards still water. Now, let us wander through the philosophical horizon that wormholes invite us to explore. Horizons, in physics, are boundaries beyond which information cannot reach. Black holes have event horizons, surfaces from which nothing can escape. Cosmology has particle horizons, the limits of what we can observe because the universe has not existed long enough for light from beyond to reach us. Wormholes, in this context, act like bridges between horizons, suggesting that the boundary of the possible might be broader than we think. In a poetic sense, horizons represent the edges of our understanding. Every time humanity pushes one of these boundaries, new knowledge spills in, expanding our sense of wonder. The telescope extends our gaze across galaxies. The microscope reveals the intricacies of cells. Wormholes extend imagination itself, offering a glimpse of realms we cannot yet reach. They encourage us not to fear what lies beyond our horizon, but to dream gently of what might exist there. The possibilities wormholes hold are numerous, even if still theoretical. They could, in principle, provide shortcuts for space travel, allowing civilizations, if any exist, to traverse cosmic distances without waiting generations for their ships to cross interstellar voids. They could connect regions of the universe isolated by expansion, allowing information to pass where it otherwise could not. They might even link separate universes, if multiple universes exist, forming subtle conduits through a grander cosmic structure. Each of these possibilities carries its own quiet fascination, inviting the mind to drift across unimaginable scales. Even if these ideas never materialize, their beauty remains. Wormholes show us that the universe is not limited to what we can see or touch. It contains mathematical landscapes far beyond our immediate experience, landscapes that reveal a kind of creativity woven into the laws of relativity. Thinking about these structures gives the mind room to breathe, to imagine widely without pressure or expectation. In a world so often filled with noise and urgency, this spaciousness is a gentle gift. As we slowly transition toward the closing chapters of this cosmic journey, it can be soothing to reflect on how wormholes help us reframe our understanding of distance and separation. In the grand scale of the universe, every point in space is connected to every other through the cosmic fabric. Gravity binds systems together, energy flows between particles, light travels steadily across interstellar space, carrying information from stars long gone. Wormholes are simply the most elegant expression of this tendency toward connection, suggesting that even the most distant galaxies might be closer in the deep geometry of space-time than they appear on our flat maps of the sky. In this way, wormholes become not only scientific curiosities but gentle metaphors. They mirror the way our lives contain hidden passages, moments when time feels folded, when memories return unexpectedly, when emotions travel instantly across distances we thought were too great to bridge. Just as a wormhole bends space into a graceful shortcut, the human heart bends experience into gentle continuity, finding closeness where none should exist and comfort where distance once felt daunting. As the night grows deeper still, imagine that you are floating once again in the quiet corridor of a wormhole. The walls shimmer with star-reflected light, curving around you like the inside of a softly glowing seashell. Ahead lies a distant region of the universe, perhaps a spiral galaxy turning slowly like a cosmic lantern, perhaps a calm nebula drifting like a cloud of color. Behind you lies everything familiar. You are suspended between them, not needing to choose, simply resting within the possibility that the universe offers pathways both outward and inward, both infinite and intimate. Imagine the night settling into its deepest calm. The sky above seems broader now than when we first began, as though each moment of gentle reflection has widened its horizon. The stars look softer too, no longer bright points in a distant darkness, but delicate lanterns spread across a velvety sea. By now, the idea of wormholes, these subtle, theoretical tunnels carved into space-time, may feel less like an abstract concept and more like a serene companion, guiding your thoughts with smooth, effortless curves. We have wandered through their geometry and their symbolism, and now, in this last part, we travel not to learn more, but to settle into the peacefulness these ideas inspire. As we continue, picture yourself floating in the quiet expanse of the cosmos. There is no coldness, no vast emptiness, only a soft, enveloping stillness that holds you gently, the way deep water holds a drifting feather. The stars glow around you like scattered embers of an ancient fire, each one burning with a patient light that has endured for millions, sometimes billions of years. In this silence, the thought of wormholes becomes a lullaby, a reminder that the universe is full of subtle connections. Even if no spacecraft ever passes through a wormhole's glowing throat, the idea remains a whisper that distances may be more flexible than they appear, that the universe contains hidden pathways woven into its deepest fabric. This final portion of our journey unfolds with the soft pace of a long exhale. We are no longer tracing the exact geometry of wormholes or exploring the physics that allow them to exist. Instead, we drift gently toward the edges of their meaning, the places where scientific curiosity dissolves into quiet reflection. A wormhole, after all, is not just a tunnel through space, it is a doorway into possibility, a gesture of connection across the universe's immense scale. Even in imagination, it becomes something more intimate, a symbol of how gently the cosmos may hold its own secrets. As this night deepens around you, you might imagine walking again through the soft tunnel of a theoretical wormhole. Only this time, you are not rushing toward a distant galaxy or peering into an unfamiliar universe. Instead, you wander slowly, each step carried by the calm breath of space-time itself. The tunnel is luminous with a soft, diffuse glow, as though the very geometry of the cosmos is resting in a kind of suspended twilight. No sounds echo here, only quiet, velvety silence. The tunnel feels infinite yet comforting, curving with the ease of a winding river. You walk not toward a destination, but toward a feeling of continuity, of belonging, of gentle connection. If you pause in this space, you might sense that each point in the tunnel connects not only to distant stars, but to memories, emotions, and quiet moments of recognition. Wormholes, in their poetic essence, are not merely cosmic shortcuts, but reminders that the universe is structured in ways that exceed our expectations. They hint that reality is more flexible, more imaginative, and more deeply interlinked than it appears on the surface. In this way, contemplating wormholes becomes a meditative act, a moment of breathing gently with the universe and letting its vastness lull the mind. Over the course of our journey, we explored how exotic matter might support a wormhole, how negative energy could hold its throat open, and how the mathematics of relativity make such structures possible. But now, let yourself view wormholes through a softer lens. They are part of a universe that does not merely expand outward, but also curls inward, forming delicate folds and hidden passages. This architecture feels less like a system of mechanisms and more like the pattern of a slowly shifting dream. The cosmos becomes a tapestry woven not only with stars, galaxies, and dark matter, but also with ideas that reveal the universe's quiet creativity. As you drift deeper through this final section, imagine that the wormhole around you begins to open gently into a vast chamber of starlight. The opening is surrounded by swirling veils of light, faint but beautiful, like wisps of mist illuminated by the moon. Through this opening, the night sky stretches out in all directions. You step forward and find yourself in a quiet cosmic meadow, a place where starlight falls like snowflakes and time seems to gather in soft pools at your feet. This landscape is imagined, of course, but imagination has always been one of humanity's most powerful ways of connecting with the unknown. In this serene space, the science of wormholes becomes a gentle whisper behind you, guiding you onward without insisting on being explained. The universe here feels almost like a living presence, not conscious in a human sense, but quietly aware in its own vast way. As you stand under the starlight, you sense that the cosmos holds its mysteries with the same patience that a tree holds its rings or a river holds its currents. Wormholes fit into this pattern as subtle possibilities, rare perhaps, and certainly hypothetical, but deeply woven into the logic of space-time. They are like seeds that may never sprout, yet still belong to the forest's design. Their presence in the equations of general relativity suggests that nature is willing to imagine pathways long before it decides whether to create them. If you allow yourself to drift through this reflection, you may notice how thinking about wormholes brings a sense of spaciousness. Their existence encourages us to contemplate distances without feeling overwhelmed by them. They remind us that even in a universe 93 billion light-years wide, there may be ways in which everything is folded closer than it appears. This is not a claim of fact, but a gentle resonance, a comfort that emerges when we imagine strips of space-time curling inward like petals on a sleeping flower. The word wormhole itself carries a peaceful image. It evokes a small tunnel made by a creature wandering slowly through an apple, creating hidden passages inside something familiar. In this metaphor, the wormhole is not violent or disruptive. It is simply a natural thread of connection. When the term was borrowed by physicists, it carried that softness into scientific language. It suggested that even the enormous scale of the cosmos might be shaped by gentle, organic curves. Now imagine that you sit in the quiet, cosmic meadow, starlight gathering around you like a soft blanket. In the distance, other wormhole mouths shimmer faintly, each one leading to a different region of the universe. One opens into a galaxy where stars form inside clouds of glowing dust. Another reveals a cluster of ancient stars that have burned with steady light for billions of years. A third leads to a quiet corner where interstellar gas drifts in slow, graceful streams. You do not need to travel through them. Their presence alone is enough, a reminder that possibility stretches in every direction. As we approach the gentle conclusion of our journey, it becomes clear that wormholes, whether real or purely theoretical, serve as a bridge between scientific curiosity and deep inner calm. They allow the mind to wander without boundaries, to drift between scales of magnitude, from the tiny quantum fluctuations that ripple through empty space to the majestic sweep of galaxies arcing through the cosmic web. This movement, this flow from small to large and back again, mirrors the rhythm of thought that accompanies deep rest. The mind loosens its grip on fixed ideas, allowing shapes, images, and reflections to drift into one another without effort. This journey also reflects a truth about the human desire for connection. Humans have always looked for ways to cross distances, whether physical, emotional, or intellectual. Wormholes are the universe's own echo of this desire, a hint that distance might not be absolute, that paths might exist where none are visible. This resonance is soothing, even if wormholes remain forever hypothetical. It shows that our longing for connection is mirrored in the very geometry of space-time. As you rest in this cosmic meadow, think of how the universe holds stories in every scale. On Earth, rivers carve their way through stone, creating winding canyons and delicate arches. Underground, roots weave unseen networks that connect trees across forests. In the sky, winds sweep through invisible channels between mountain peaks. And in the universe at large, space-time itself may form hidden passages between distant stars. All of these structures, seen and unseen, speak to a deeper truth. The world around us is full of pathways waiting to be discovered, and we are part of that landscape. Let your thoughts drift now toward the gentle closing of this journey. The wormholes behind you remain luminous, each one a small, glowing reminder of the creativity embedded in the universe's deepest laws. The cosmic meadow around you fades slowly, not disappearing but dissolving into darkness as soft as velvet. You feel yourself floating once more in the quiet corridor of space-time, suspended like a lantern, gliding across still water. There is no need to reach a destination. The journey itself has become a place of rest. Far away, perhaps on the other side of the universe, stars continue to form, galaxies continue to drift, and the fabric of space-time continues to curve with serene precision. None of this requires your attention now. The universe is calm, patient, and quietly unfolding, and you are part of its peaceful rhythm. The idea of wormholes, with all their gentle wonder, now rests softly in your mind like a fading constellation. As we begin the final descent into stillness, imagine stepping slowly out of the wormhole corridor and back into a quiet night sky. The stars above you shine with their ancient light. The air feels cool and unhurried. The world is silent, wrapped in the soft hush that precedes deep sleep. You feel the peaceful weight of your body, grounded and supported, and the soft expanse of your thoughts, floating like distant galaxies on the edge of dreaming. Wormholes, those gentle tunnels of the imagination, now feel like old friends' ideas that carried you through vast spaces, yet always with soothing simplicity. They have shown you that the universe can be both immense and intimate, full of mystery yet deeply comforting. They have guided you toward the horizon of possibility, where wonder and rest meet in quiet harmony. And so, as this journey comes to an end, let yourself settle fully into the softness around you. The cosmos has welcomed you tonight with open arms, offering its quiet stories and gentle pathways. You have drifted through the geometry of space-time, walked through tunnels of light, and rested beneath imagined skies where wormholes shimmer like hidden doorways. All of this has brought you to this final moment, a moment of peaceful surrender to the night. Thank you for joining me on this gentle voyage through the relaxing science of wormholes. May the calm of the cosmos stay with you as you drift deeper into rest. May the quiet pathways of the universe guide your thoughts into dreams touched by starlight. And may the night hold you softly, the way space-time cradles every star, every planet, and every possibility. Sleep well, dear listener, and good night.